students, I'm Professor Sebastian Paul. In this lecture, we are discussing a half-wave rectifier with a filter circuit. So in the previous lecture, we had discussed what is a half-wave rectifier. A half-wave rectifier converts the alternating current into a direct current, but the obtained direct current at the output is not a pure DC, and it is a pulsating direct current. This pulsating direct current is not constant, and it has fluctuation with respect to time. When the fluctuating DC is applied to any electronic device, the device may not work properly, and sometimes the device may also be damaged. So the fluctuating DC is not useful in most of the application. Therefore, we need a direct current that does not fluctuate with respect to time. The pulsating DC contains both AC and DC components. The DC components are useful, but the AC components are not useful. So we need to reduce or completely remove the AC component. By using a filter, we can reduce the AC component at the output, and the only solution for this is smoothing the fluctuating direct current, and this is achieved with the help of a device called filter. A filter is an electronic device that allows the DC component and block the AC component of the rectifier output. The filter is made up of a combination of the components such as capacitor, resistor, and inductors. The capacitor allows the AC component and block the DC component, and the inductor allows the DC component and block the AC component. The diagram shows the capacitor is connected in shunt with a load resistor RL. When the AC voltage is applied during the positive half cycle, the diode D is forward biased and it allows the electric current through it. As we already know that the capacitor provides high resistive path to the DC component and low resistive path to the AC component. Since the DC components are low frequency signal and the AC components are high frequency signals, the electric current always prefers to flow through a low resistance path. So when the electric current reaches the filter, the DC component experiences a high resistance from the capacitor and AC component experiences a low resistance from the capacitor. The DC component does not like to flow through the capacitor, so they find an alternative path and flow to the load resistor RL through that path. On the other hand, the AC component experiences a low resistance from the capacitor, so the AC component easily passes through the capacitor. Only a small part of the AC component passes through the load resistor, which produces a small ripple voltage at the output. The passage of the AC component through the capacitor is nothing but charging of the capacitor. So in simple word, the AC component is nothing but an excess current that flows through the capacitor and charges the capacitor. This prevents any sudden change in the voltage at the output. During the conduction period, the capacitor charges to the maximum value of the supply voltage, and when the voltage between the plate of the capacitor is equal to the supply of the voltage, the capacitor is said to be fully charged. When the capacitor is fully charged, it holds the charge until the input AC supply to the rectifier reaches the negative half cycle. When the negative half cycle is reached, the diode D gets reverse biased and it stops allowing electric current through it. During this non-conduction period, the input voltage is less than that of the capacitor voltage. So, the capacitor discharges all the stored charge through the load resistor RL. This prevents the output load voltage from falling to zero. The capacitor discharges until the input supply voltage is less than the capacitor voltage. When the input supply voltage is greater than the capacitor voltage, the capacitor again starts charging. When the positive half cycle is reached again, the diode D is forward biased and allow the electric field. This makes the capacitor to charge again. The capacitor filter with a large discharge time constant will produce a very smooth DC voltage. Thus, smooth and steady DC voltage is obtained by using a filter circuit. So my dear students, in this lecture we had discussed how to smooth a pulsating DC signal of a half wave rectifier. So as we mentioned, for this purpose we had used a filter circuit. So as we mentioned, during the positive half cycle, the diode D is forward biased and the capacitor C becomes charging during this positive half cycle, since the AC current flow through the capacitor circuit, and during the negative half cycle the diode D is reverse biased and there is no current in the output section. But during this negative half cycle the capacitor begins to discharge the stored charge, and this discharge charge will flow through the load resistance RL, and thus it makes a smooth output in the load resistance RL, since the capacitor with a large discharge time constant will produce a very smooth DC voltage. So dear students, hope you had understood this concept. So dear students, kindly write down the assignment question. Our question is, write notes on the usage of capacitor filter in a half wave rectifier. So dear students, in the upcoming lecture we will discuss what is a full wave rectifier as well as what is a center tapped transformer circuit. So dear students, see you soon. Until then, goodbye, thank you and all the best.